Hello everyone, I am Santosh Bothe, working at Daksh Foundation, Pune. We are working on a project called Disease Diagnosis using audio samples. The proposed layout of the system is something like this. The left-hand side picture indicates that when we speak, each and every organ contributes its own role or plays its role while speaking. That reflects the status of that organ which are contributing into production of that voice. That voice samples will be then passed to the computer. Computer will be having a clear distinction between the normal values of the parameter and the disease values of the parameters. Then this normal and disease value will be compared with the centralized database for the mapping it to the particular disease. After mapping it to the disease, if the person has the disease, it will be informed, announced in appropriate mode, or the person can be diagnosed a healthy person. So this is how the proposed system is planned to work. When we speak, there are multiple audio channels, as many as 24 audio channels, out of which only 6 audio channels are audible to the human. Each of these audio channels are having multiple parameters, like 12 parameters: peak amplitude, wavelength, distortion, frequency. Like this, there are 12 parameters. The combination of these audio channels, 24 audio channels and 12 parameters, gives rise to 24:12 permutation combination. Now what we found that each of this combination is associated with some disease, disorder, malfunctioning of the human system subsystem. In short, the combination of these parameters can act as a unique audio signature of an individual health status. Means it can reveal your current health status, like whether you have some disease or disorder. Some of the combination are very specific to the organ and disease. For example, some are specific to the heart, some are specific to the lungs, the livers and brain, vision. So if there is a disease or disorder associated with that particular segment of the human body, it is going to be reflected into this audio spectrum. So we received very interesting results for leukemia. If the person has a blood cancer, the channel number 3 shows a peak amplitude variation of ±6. That means a person has a leukemia. We validated with more than 1000 samples. In all cases, we are getting almost acceptable results, means 99% accuracy in all the cases. So we are getting very promising result in early stage for the channel number 3, like in terms of variation of a peak amplitude. Now what we want to expand this for all over the body, especially in case of infectious disease. Suppose there is outbreak of H1N1 and we wish to detect the H1N1 infection through the mobile phone. Asking everyone to carry out the pathological test is not a feasible task. So what we thought of, we will develop a system, a centralized computational system, wherein the user can call to the IVR system, record his 30-second audio. We need only a 30-second audio sample of the patient, voice sample of the patient. So that 30-second voice sample will be collected from the remote location. The user who intends to check the infection of the disease will call the IVR system. The IVR system then collect the voice sample of the user for 30 seconds. That 30-second voice sample of the user will be passed on to the central analytics system. The analytics system will compare the audio signature of the patient with the disease signatures. If it is matching, means if system is diagnosing that person is having the infection, it will be passed on to the appropriate information and decision making system, and the user will be communicated via appropriate mode, which is into a medical ethics, and the disease can be controlled. In near future, if it is successful, it can replace the entire diagnostic mechanism with a totally convenient and affordable solution for each individual, for each human being. Thank you very much for watching our video.